All right, so this is part 2 of chapter 5. So, monsoon system. The monsoon system it's similar to the other systems that we've been talking about, but on a much larger scale. So, so we have here July and January. So in July, right, summer, it's hot. The landmass of Asia, the air masses are heating up, right? And so again, it's low pressure, so the air is going up, right? Remember again, warm is low pressure, cold is high pressure. And so it brings in the air from the ocean during summer. And as you can imagine, that air is saturated with moisture. If anyone's ever been to Asia in the summer, you're talking some high heat and humidity. When I was in China, I tell you, step out of your hotel room and you're just drenched wet instantly. Just so much moisture in the air. And then you have things that also contribute to the large rains, like mountain chains. So in the Himalayas, there for as an example, this is why you very often hear about the monsoon season in India specifically, is because, well, that very very moist air goes over there and dumps a lot of rain. And as you can see in January, it's the opposite, right? High pressure, right? Much drier. Excuse me. So there's a number of global pressure belts. I have another sip of water. Hold on a second. So let's start at the North Pole and the South Pole. As you can imagine, that's some very cold air, right? And as hot air is going up, that cold air is coming down. You could look at those arrows. See the air mass coming down, right? So that very cold temperature starts these pressure belts, right? Now, if you look at the equator, that's hot air. So if you look at those arrows there, that air is going up, right? And so you have these air systems that are necessitated because of these very cold and very warm temperatures on the Earth. And you see that there is a middle section there. If you look into connecting the subtropical high and the subpolar lows, well, that little section there is created from the other two systems, right? So these pressure belts that we just saw, they're general trends, right? This makes it look like the whole Earth has the same pressure belts all the time. Well, no, there's things that happen in different seasons. There's ocean currents and all kinds of different things going on. This, like many other things we learn, are general trends. Some important wind patterns. Again, the doldrums there. Tropical easterlies. So, well, if it's called an easterly, where does it come from? The east, right? Things are named after where they come from. But this is another good depiction of what we were talking about. You could read about this. Similar things. As you can see, this anticyclone here, and in general, the pattern is moving to the right because it's north of the equator. So strong upper air westerlies are referred to as jet streams, right? In a nutshell, again, the Earth is spinning, and think of it like, when they have a magician who is at a dinner table and they pull a tablecloth off really quickly, and the dishes don't go all crashing. Well, think of the Earth spinning, and the things on the Earth's surface, primarily our atmosphere, they're kind of like the dishes, right? As the Earth moves, those dishes, when when the magician pulls out the tablecloth, if you look, those dishes don't actually stay in the same place. They move a bit, right? They're dragged a bit. Well, it's a similar thing happening with our atmosphere. So in general, the further up in our atmosphere you go, the less of that drag is happening from the Earth's surface, and so you're going to have quicker winds. Hope that makes sense to you. Well, you could just read about this. Well, this lower right map looks a little bit like what you'll see in weather reports and whatnot. Well, this is just showing you how these different weather systems can kind of intermingle, and you could have high fronts and low fronts merging and moving into each other, this type of thing. Again, more examples of the ocean currents. As we know what direction in general they turn to, but they also have cold currents and warm currents. As you can imagine, around the equator, you have warm currents, right? And for the north and south, you have in general cold currents. You could read about all this. El Nino. This is something that's in the news quite regularly because sometimes you can predict longer term seasonal changes. So what is El Nino? Basically, it's when you have off the coast of South America, you typically have these cold coastal waters. Well, every now and then the system gets mixed up and you get warm water instead. Some think this may be part of a larger warming trend. It does seem to be happening more lately. And the opposite is called, and I have El Nino there, but of course it should be La, because that's the feminine Nina. All right. So here's a good depiction of why does it matter? How does this change weather patterns? Because the water temperature is going to be different at different times. Well, basically that shifts around where that moist water is going at different times, right? So you may live in a community who is used to you're getting your rain at a certain time of year in a certain way. Well, if everything shifts, let's say as an example, you're living in Minnesota, and let's say that strangely we get all of our precipitation in winter, we get tons of snow, but then no precipitation in summer. Well, that really throws things off as far as planting crops and whatnot. All right, and that is the end for chapter 5.